All right, here we go. Last section in chapter 3. We're dealing with everybody's favorite word problems, otherwise known as black highlighter, nice. Otherwise known as applications of rational expressions. Okay, so very important. Oftentimes we jump to conclusions on these things and we're like, I can't do them without even reading, without even looking at them. Read the problem carefully, sometimes a number of times. Identify the info within that question. It's just words representing these numbers, right? Use variables to represent the unknowns and try your best to represent everything in terms of the same variable. All right? Make a diagram or a drawing to help you out. So let's jump to it. Example 1. Words that jump out to me. Sum, number, reciprocal. All right, so sum means plus. Number, well, I'm going to say let n be a number. So plus twice its reciprocal. So if n is the number, its reciprocal is 1 over n. Twice that is times 2, which means 2 over n. So n plus 2 over n is equal to 9 over 2. That's what I'm trying to solve. What is n? Well, multiply this whole thing by n, 2n, to get rid of the denominator. We're going to have 2n squared plus 4 equals 9n. We're going to get everything together. Minus 9n plus 4 equals 0. And we are going to factor 2n, n. My back numbers need to multiply a 4 and add to negative 9, which means they're both negative, and I'm going to need a 1 and an 8. So the way to get that would be like that. So that means n is 4, and n is a half. If we test both those numbers in our equation, you'll see that it holds true. If n is 4, we have 4 plus 2 over 4 has to equal 9 over 2. Well, 4 plus 2 over 4 is just 4 and a half, and so is 9 over 2. And if we have a half, you have a half plus 2 over a half. Now 2 over a half is 4. So again, you got 4 and a half. So we know that both of those work. You're good to go. Let's look at something a little bit more involved. So with example 2, where's my info? Here, distance. Sorry, let me get the highlighter. Distance. And I don't want that color highlighter. So let's try that one more time. Distance, 4 kilometers. They both finish at the same time, but Nikki starts 1 minute before Matt. Problem is we don't know Matt's time. All right, so we don't know time. Matt travels 1 kilometer an hour faster than Nikki. So we're dealing with speed. Now, some of you might be learning how to drive. Most of you have been in a moving vehicle at some point. So you know that speed is equal to distance over time, right? Kilometers per hour. So, also look at our units, kilometers per hour. Except here we have 1 minute, right? So it's given to you here, write 1 minute as 1/60th of an hour. So I'm going to make a little table. And in this table, we're going to put all this information. So we got the person, and then we have distance, time, speed. And we have Nikki, and we have Matt. So a few things we do know. We know that they both go 4 kilometers. We don't know Matt's time. We don't know Nikki's time. We'll do that in a minute. But speed we do know. We know that if Nikki's speed is unknown, we know Matt is 1 kilometer per hour faster. And that's where we can use this now to get time. Now this equation solves for speed, but if we just do a bit of algebra, time is equal to distance over speed. So we can represent their times as 4 over x and 4 over x plus 1. So now we have enough information. Because what do we know? We know that Nikki starts 1 minute before Matt, which means Nikki's time minus Matt's time is equal to 1 minute, or 1/60th of an hour. So this is what we work out. So Nikki's time is 4 over x. Matt's time is 4 over x plus 1. And that equals 1 over 60. So let's scroll over so we got a little bit more room. What's the common denominator? Well, it's x times x plus 1 times 60. So let's multiply this whole thing by that. Right? We're essentially water bombing in the lowest common denominator, and our common factors will cancel. So for the first one, the x is going to cancel. We're going to be left with 4 times x plus 1 times 60 minus the x plus 1 is going to cancel, so 4 times 60 times x, and then the 60s are going to cancel x times x plus 1. Water bomb the 4 and the 60, so we're going to have 240x plus 240 minus 240x equals x squared plus x. We see here cancel. We're left with, let's get everything else together, so we're left with x squared plus x minus 240. Two numbers that multiply to 240 and add to 1. Now, there's a few little tools you can do to find that out, but I need you to consider your two factors have to be close together. And 240 ends in a 0, so if you times it by 10, it's 10 times 24. Those aren't close together, so it's got to be a number bigger than 10. If you try a few numbers through, you'll find that you get x plus 16 and 15. So that means x equals negative 16 or positive 15. Well, obviously we're talking speed, so negative 16 doesn't work. X is 15. But who's x? Right? Let's scroll back. Whose speed is x? Nikki's. So that means Nikki is traveling 15 kilometers per hour. And since Matt travels 1 kilometer faster, he's 16. So I know that can be a little confusing with the speed and the distance and the time, but you're going to see a lot of questions with that sort of build up. So watch that again if you have to. Make sure your units are correct, and just work your way through slowly. Let's move on to this next one. So this next one is what we call an average time question. These are also a little bit more challenging. So brace yourself. Okay, so read the question. Cold water tap can fill a container 2 hours faster than a hot water tap. Well, there's some information. Okay. The two taps together can fill the container in 80 minutes. How long does it take for each tap to fill the container on their own? So I've left in a little bit of information here for you. Okay. Here's what we're given. Let x, so see we've identified a variable, be the number of hours it takes for the cold water tap to fill the container alone. Well, we know that the cold water tap fills 2 hours faster. So then the hot water tap must be x plus 2, the time of the cold water plus 2. So that's alone, right? Now, the question is now in minutes. Well, everything else is in hours. So what's 80 minutes in hours? 80 minutes times 1 hour per 60 minutes. Units cancel. 80 over 60, which is 4 over 3. So 80 minutes is 4/3 of an hour. So now we got some time. Okay? And if we make a little table, just like we did last question, you can put some information in it, okay? You can just put some information about time, and we can put some information in rate. So we got cold, we got hot, and we got together. So we know that the cold water tap, we said at the beginning, takes X. We know that the hot water tap takes X plus 2 to fill by itself. And we know together, it takes them 80 minutes. So 4/3 of an hour. Now the rate, if we put it in per hour, right? If it takes X per hour, it takes 1 over X. It's an average per hour. And then 1 over X plus 2. And then we take 1 over the 4 over 3 to make everything 1 over. And we get 3 over 4, because now we've taken our rate per hour. So now we got a bit of things that we can work with. All right? So if we take our rates here, we know that the cold water tap fills at that rate, 1 over its full amount of time, right? We know that the hot water tap fills at that rate, and we know that together it's going to take 3/4 of an hour. So work this through. LCD is 4 times X plus 2. So what's missing from the first one? X plus 2 and 4. So 4 over X plus 2. What's missing from the second one? 4X. What's missing from the last one? X times X plus 2. If we wrote all the denominators in, they would just cancel out. So I killed that off in one step. Water bomb in the 4X plus 8 plus 4X equals X squared plus 2X. Get everything together. Oh, sorry. Times 3 over 4. So we just have to change this. We're multiplying. The 4 is going to cancel. So, sorry. The 4 cancels with the 4. This 4. Rewind. Sorry, guys. Here we'll multiply by the LCD. The 4 stays. The X plus 2 stays. Here we multiply by the LCD. The 4 and the X stay. Here we multiply by the LCD. The 4 goes, but we're still multiplying by 3. And I don't know why I changed color, but oh well. So we actually have 3x squared plus 6x. Sorry about that. Now get everything together. 3x squared plus 6x minus 8x minus 8 equals 0. 3x squared minus 2x minus 8 equals 0. Now again, we know we're going to have a 3 and a 1. And then we're looking for two numbers that multiply to negative 8 and add the 2. So with the 3, we're going to have a 6. So minus 2, that gives us negative 6x plus, should be a 4, plus 4. That'll give us everything we need. So we have x equals 2 and x equals negative 4 over 3. Again, can't have negative because that's time. So x is 2. So that means the cold water tap can fill in 2 hours. The hot water tap fills in 4 alone. Cold water, 2 hours. Hot water, 4. Now this is not the easiest thing to do, but what it comes down to is identify their times in total, right? Because it took them X amount of hours. So that means 1 over X is 1 hour, right? Think about it. If it took you 4 hours to do something, you would fill 1/4 of it in an hour. That's what we're looking at with the rates. All right. Another one. We got another speed question. Now I've broken down a little bit here for you already. So car travels from home to work at an average speed. Now this obviously with math is not realistic. You can't travel at an average speed because our cars accelerate and decelerate all the time. So this is where you got to give the math a little bit of a carte blanche because we're not into physics. And it takes a lot more complicated mathematics if you consider all of the different acceleration and deceleration speeds. So this is an important aspect. Average speed. But we got two things going on here. We got an average speed on the way home, and we got a car travels from home to work. So on the way to work, average speed of 60 kilometers per hour, and on the way home, slower, 40 kilometers per hour. So we've got some things labeled. We have time to travel, the distance, which we don't know, right? To work is distance over 60, because we know it takes 60 kilometers per hour. So whatever distance that takes gives me just the time. Same here. Time to travel, returning from work, distance over 40. Now again, if you want me to break that down, distance is equal to time. Distance equals time times speed. And if you divide that by a speed, distance is time times speed, which is kilometers per hour, but then you divide it by 60, which is kilometers per hour. The kilometers per hours cancel off and you're just left with hours. So we have a time here, distance over speed. So I'll just erase that because I realize I wrote it right here, distance over speed. So that's where we get those two times from. We don't know the distance, we do know the speed. Now, an average speed of X kilometers per hour, the time is 2d, right? Because the distance goes, same distance, twice. So distance over speed is 2d over x. So now, okay, we got a few things. I got a whole bunch of times, right? Well, here's what we have. We have time going to work, and we have time returning from work, right? And that gives us our total time. Thing is we don't know what any of those times are yet. We only have them with respect to distance over speed. But we know that time going to work is distance over 60. Time coming home is distance over 40. And total time is 2 times the distance over our unknown speed. Since distance is a constant, it's irrelevant. We can just set it equal to 1. It doesn't matter what the distance is, right? It's the same distance in every scenario. So no matter what number you threw in there, it's not going to affect the question. So to make life as easy as possible, let d equal 1. Okay? So we have 1 over 60 plus 1 over 40 is equal to 2 over x. Now you can't always just make things irrelevant like that. It's a specific scenario in this question, and that's the hardest thing to come up with. So let's just slide this over. We're solving this. Equals 2 over x. So our LCD, our lowest common denominator, is 60 times 40 times x. So we need to multiply everything by our lowest common denominator. All right, that's going to be a very large denominator, not our lowest common denominator. Common multiple of 60, 120. Common multiple of 40, 120. So our LCD is actually 120x. Multiply everything here by 120x. 120 cancels with 60, we're left with 2x. 120 cancels with 40, we're left with 3x. The x's cancel on the end, we're left with 240. Add that side, divide out the 5, x is equal to 48. So we solved our average speed, 48 kilometers per hour. Again, another quite challenging concept. That's why you guys hate these so much. All right, so let's continue. We have 2 more to go. Now this one here is another example of the average time and the rate of time that we did in the water question. So here we have Aaron, who takes 9 hours longer than Chris to paint a house. Working together, they can do it in 20 hours. So how long would it take each person to do it working alone? We don't really have that information, so we gotta work it out. If X is the number of hours Chris needs to complete the job alone, then X plus 9 is the number of hours Aaron needs to complete the job alone, because Aaron takes 9 hours longer. Now, if Chris completes the job in X number of hours, then he works at a rate of 1 over X, right? Again, if it takes him 5 hours, then he gets 1/5 of it done in an hour. Aaron works at the rate of 1 over X plus 9. If it takes them 20 hours to do the job together, Chris completes 20 over X of the job, because that's his hourly rate, and Aaron completes 20 over X plus 9 of the job. In 20 hours, they would complete 1 job, right? 20 hours, they would complete 1 job together. So that's where we get our equation. We get that Chris plus Aaron equals 1, right? Because this job that takes 20 hours, Chris can do that much per hour, and Aaron can do that much per hour. So you add them up together, and they'll finish 1 job. So what's our lowest common denominator here? X times X plus 9. So first one, the X's cancel, so we get 20 times X plus 9. Second one, the X plus 9's cancel, so we get 20X, and then times 1, so X plus, or times X plus 9. Work this out. We get 20X plus 180 plus 20X equals X squared plus 9X. Let's get everything together. X squared plus 9X minus 40X minus 180 equals 0. Let's continue along. Now again, we have to factor this, and we want to make it as easy as possible. You know that 18 ends in 180, so your numbers have to multiply to 180, so you could think, well, 18 times 10, right? But those add to 28. So we actually need to go the other direction. Think if you went higher, if the numbers got closer together, say you had 12 times 16, you'd be at 28 still. Or, 12 times 16 doesn't equal 180. But what else? How about a 5? 5 times what? 5 times 36. Can you get to 31 using 36? You sure can. One of them is going to be negative. That one. So this factors to X minus 36, X plus 5. We get 2 values for X. We get X equals 36, and we get X equals negative 5. One of those won't make sense because we're talking about, what are we talking about, right? What is X? Come back up here. X is the number of hours Chris needs to complete the job alone, right? So Chris needs 36 hours, and Aaron is X plus 9. So 36 plus 9, 45 hours. These rates of time questions are tricky. I'm not going to sugarcoat this for you. This is some challenging stuff, right? This is a mathematical representation of this physical concept. So no doubt you might be a little frustrated. Look through again, read through the notes online as well. It's all there. Take your time, try to wrap your head around it. Email me, shoot me a message if you're still super unsure, and I can try and clear it up for you. We got one more. It's another distance time question. It's very, I don't want to say famous, but in your grade 11, 12 journeys, you're going to see this type of question a lot. I didn't blank it out because I'm just going to read you through it. We have a speedboat that can travel 108 kilometers downstream. Okay, so we got a distance. It can travel in the same time. It can travel 78 kilometers upstream. So in our table, we have two different distances. Downstream would be with the current, so 108 kilometers. Upstream would be against the current, so 78 kilometers. The current is 10 kilometers per hour. What's the speed of the boat in still waters? If the water's not, if there's no, still water. So with the current, it's the speed of the boat. We're saying x plus 10, right? Because you get the speed of the boat and the speed of the water pushing with it. Whereas against the current, you take the speed away, and then we have our time equation, distance over speed. Now, where we get this from is what's the speed? We know two different speeds, right? And what's equal in both scenarios? Time. It can travel in the same amount of time, which means both times are equal to one another, which is why we set them equal. And then we just work our way through, solve for x. X is 62, so remember x is the speed of the boat, so speed of the boat is 62 kilometers per hour. Honestly, it's all about setting up this thing in other questions and knowing your speed. So really quick bit of algebra for you before we go. Speed equals distance over time. If you multiply both sides by time, speed times time equals distance. If you divided both sides by speed, time equals distance over speed. Those are the three different scenarios. Okay, so that concludes chapter 3. Chapter 4, we're actually going to get into some graphing and some quadratics and solving with quadratic equations and solving with square root methods. It's a nice math-heavy, algebra-heavy, but quite rewarding section. I enjoy it. So more videos to come, and then we're going to work through as much as we can. Remember to keep an eye out on the website for information, emails, and potentially Google Classroom. Okay, guys? Have a great rest of the week.